Welcome everyone to today's webinar that is part of Low Carbon Learning. The topic today is titled A Whole House Scottish Retrofit, delivered by Barbara Lantschner, Associate Director from John Gilbert Architects. Low Carbon Learning is funded through the National Transition Training Fund, funded by the Scottish Funding Council, where we have been upskilling and reskilling in passive house and retrofit standards. We continue to deliver online courses and practical courses such as the Passive House Contractor Training, Understanding Domestic Retrofit, and the Retrofit Coordinator course, and many more courses and training opportunities are available. Low Carbon Learning aims to support the industry in achieving a net zero built environment. Today, Barbara will discuss whole house retrofit in a Scottish context, and in particular, EnerPHit, a project named Niddrie Road, which some of you may have heard of. My name is Caitriona Jordan, and I am Head of the Retrofit Programmes here at Construction Scotland Innovation Centre. If you have any questions in regards to the programme Low Carbon Learning, please get in touch with myself. Before I hand over to Barbara, I just want to cover some housekeeping. If you want to ask a question, please click on the question icon on your right-hand side of the screen and post it there. We will try and answer this in our question and answer slot at the end of Barbara's presentation. The webinar will be recorded and the link will be posted on our social network channels, and we will also issue it through a follow-up email. Finally, there will be some polls throughout the webinar, which we are really keen for you to participate in, and after the webinar, we will also issue an evaluation form. Please complete it, as it really helps us to provide the best service that we can. Here is a short video capturing our project. And here is our first poll. On a scale of 1 to 5, what is your level of knowledge of EnerPHit as a standard for retrofit in the built environment? So 1 being no knowledge at all, and 5 being an expert. If you just select your choice, and the results will just be posted in a minute. So we have quite a wide range of knowledge in retrofit and EnerPHit, so that's really great to see this morning. Barbara is an experienced building performance specialist, leading Hab Lab building performance evaluations service and deep retrofit projects at John Gilbert Architects, focusing on post-occupancy evaluation, energy efficiency assessment, energy modelling, indoor air quality, ventilation, and much more. Barbara holds a wide range of sustainability accreditations, including the Level 5 diploma in retrofit coordination, risk management, and she is also a certified passive house designer. Barbara has also been instrumental in supporting Construction Scotland Innovation Centre with low carbon learning, and in particular our immersive learning modules, which I'll mention later. Welcome, Barbara. Thanks for joining us today.
Hello, good morning.
Hi there. I'll just switch off my camera and leave you to it. Thanks now.
Problem. Can you see my screen? Is that okay?
Yep, perfect.
Great. Okay, good morning, everyone. Thanks very much for that presentation, Katrina, and thanks everyone for attending this webinar. So yes, I will be talking about a whole house retrofit and our experience in the last years on implementing this whole house retrofit strategies across Scotland. So this is how I'm going to structure my presentation. I'll first talk about the context and a little bit what deep retrofit and whole house retrofit means. I'll then talk about, guide you through the different retrofit standards and specifically the ones who follow this whole house retrofit approach. After that, I'll be talking about HAPLab, which is a building performance evaluation service within John Gilbert Architects. And the reason why I'm going to talk about that, it's because it's very much linked of all the topics that we're going to talk about today. I'll then talk about different whole house retrofit strategies, and the rest of the presentation, which is about 50%, I'll guide you through. I'll use Niddrie Road as an example of how we implemented many of this strategies. So why are we talking about retrofits so much? And also to say, my role within John Gilbert Architects is I'm working 95% of my time on retrofit projects, so we are taking it very seriously. It's not only me in the office who works on retrofit. It's have several colleagues working on that, and we also work on conservation and trying to merge these two type of projects to follow this whole house retrofit approach that I'm going to explain shortly. But why do we think, in the wider context, why is it so important? Well, first of all, housing is the fourth largest sector of greenhouse gases and emissions in the UK, accounting for 40% of the overall emissions. So that's that puts a lot of pressure in our industry in trying to find how to decarbonize the industry. 80% of the homes we will be using in 2050 already exist. This is specific to the UK. Different countries have that rate, of course, varies from country to country, but what happens in the UK is that there are a lot of existing buildings, and many of them are underperforming, and that's what I'm going to touch on when we'll be talking about what we did and what we are still doing for HAPLab. And the third important point that I wanted to touch on is that poor housing costs the NHS over 600 million each year. That's a fact was published by the BRE. So it's not only about carbon emission targets. It's about future-proof. It's about also living in warmer, affordable, and healthier homes. And so what is actually whole house retrofit and deep retrofit compared to standard retrofit? Retrofit, it's the upgrading of a building to enable it to respond to imperative of climate change. That's a quote that I took from a very interesting book. That's Residential Retrofit 20 Case Studies. It was published several years ago. But I think that summarizes well what retrofit is. It's to upgrade buildings that were designed for the needs of previous times and now need to meet the needs of today's climate emergency scenarios and other targets. A deep retrofit takes a whole house retrofit approach by looking at the overall effect of a combination of the most appropriate energy measures. It also considers the architectural significance of existing buildings and how residents interact with the building systems. Instead, shallow retrofit or conventional retrofit, or what we knew about retrofit until now, does not consider the interaction of the building elements. For example, and this is something very common, it's someone upgrading the building fabric without analyzing or evaluating how that would impact indoor air quality or ventilation. So even if you're just installing one measure, you need to understand how that will impact the other building systems and have a plan in place to mitigate risks. So there are many publications out there, many guides, very useful guides, and there has been a lot going on lately. Last year, we saw very interesting guides that I'm going to expand. I will touch on in the next slides. One that I'm not going to talk about, and I suggest you to have a look. It's the Sustainable Renovation Guide, that it's free to download, was written by Chris Morgan, who also works for John Gilbert. He's a director at John Gilbert Architects, and this was prepared for the Public Trust and CEDA, and Historic Environment Scotland. I do suggest you to download that guide, which is very much linked to sustainable renovation in the Scottish context. So talking about deep retrofit versus shallow retrofit, if we focus on the climate change targets and what we see in the graphic there, if we actually want to meet that transition to net zero and continue with implementing shallow retrofit or not a whole house retrofit, that will mean that the space heating demand or the carbon emission savings are going to be about 30%. And that, as the graph shows, is not sufficient. We need to meet the targets. We need a robust plan in place, and that requires deep retrofit. If the retrofit plan is staged or not, that we will cover that later on. There are different ways of implementing it, but it needs to be deep retrofit and a whole house retrofit. So of those graphs, by the way, I took them from the Letty guide, which I'll also going to cover in this presentation, but I also suggest you to have a look because that's also a free resource. Deep retrofit is not only about energy consumption reduction, it also helps us to mitigate fuel poverty, provide warmer and healthier homes, provide affordable to run homes, improve maintenance programs and future-proof properties, and improve market value and aesthetics. So they're very interesting, as I was mentioning before, there's been a lot of going on in the retrofit industry. There are a lot of very interesting publications out there and very interesting standards which follow this whole house retrofit approach. What you see on the screen are some of the standards which follow this deep retrofit and whole house retrofit approach. The ones that I've marked and highlighted are the ones that we're using the most, but that's something that we have chosen to use within John Gilbert Architects, and mainly EnerPHit and PAS 2035. For some of our projects, we also have been using the AECB standard. So PAS 2035, I will also cover PAS 2035 in my presentation because I'm sure that you've already heard about that. It's now a requirement for some of the funding streams, for example, ECO3. So, it's not proposing a specific performance target, but it provides a best practice guidance and quality assurance for domestic retrofit. And one of the things that some of the standards provide, for example, EnerPHit, I would say specifically EnerPHit, it provides a modeling tool to be able to accurately predict how a building will be performed, how will it perform after we implement the retrofit measures, and what that will basically minimize performance gap issues. The other very interesting thing that EnerPHit provides, it's a quality control and a certification scheme. So all of this will minimize as much as possible the performance gap. So in our office, we are, I think, 6 passive house designers currently. Some of them work 6 or 7, I think. Some of us work on mainly on retrofit. That means that we implement EnerPHit, which is the passive house standard for retrofit, and others work mainly on new build. But we have adopted this scheme because we think it's robust and it minimizes risks throughout the project. So, so what's EnerPHit? So passive house proposes, as you probably know, stringent performance targets, which are great because it ensures that the house will be not only efficient and cheap to run, but also comfortable, and it will future-proof the project. But in the case of existing buildings, we're not able to control many of the parameters, such as orientation, structure, occupation, shape, or the amount of glazing. So because of that, Passive House several years ago developed the EnerPHit standard, which takes into account all these limitations. So basically what it does is to make relaxes some of the criteria that are used for new build. So it's not exactly the same the new build, but it follows the same methodology. It also suggests to use PHVP, which is the energy modeling tool. It still insists on making a building as airtight as possible, but at the same time providing a robust ventilation strategy. And overall, the benefits of EnerPHit compared to other standards are that it minimizes the performance gap as low as you possibly can, improves comfort and well-being, future-proofs buildings, allows to adopt a component-based approach, and also a step-by-step methodology. Past 2035 is, as I mentioned before, it's not proposing a specific performance target. So it's not focusing, let's say, on a specific air tightness target or energy consumption target or space demand target. What it does instead, it's to provide a best practice guidance on how a retrofit project or what process it should follow to ensure and that we are minimizing the performance gap. So it also works around performance gap. It follows a whole house retrofit without necessarily proposing a specific performance target. It was released in July 2019. That's a couple of years ago, but the industry is still trying to adapt to it. Intending to support the Each Home Counts, which I also invite you to read it and to go through it, because it was in response to that this retrofit standard was prepared. And it's important to remember how things were working and how the industry, what were the main issues that the industry were facing and are still facing, and how the standards proposes how to mitigate those risks and issues. So it provides a specification and best practice guidance for energy retrofit works, specifying the right retrofit measures in a holistic way, assessing the interaction between measures and minimizing performance gap issues, assessing ventilation, the ventilation was not really in the scene unless you would work with EnerPHit and these other standards that I mentioned before. Until now, there wasn't really a need of thinking, and there was no, at least not a guidance in the UK suggesting that ventilation had to be part of a retrofit strategy. So assessing ventilation and indoor air quality aspects, assigning a project manager, which is the retrofit coordinator, to overview the process, ensuring appropriate qualifications. That includes resources assessor, advisor, evaluator, etc. Ensuring that monitoring and evaluation takes place before and after retrofit measures are installed, which is done by the retrofit evaluator. Provides feedback to improve the whole process, not only to clients and architects, but also to the whole industry. And as I mentioned before, it's now an eco-funding requirement. So a little bit about HabLab. I started at JGA actually as a building performance specialist, working 100% of my time on building performance evaluation, and that it's HabLab, which is a consultancy service within John Gilbert Architects. And it actually started about 7 years ago as a project, and we managed to, and it's now a service, and it's several of us working on it. What we do is we provide building performance evaluation for clients. Most of our clients are housing associations and local authorities, but we have done it also for private owners, and we have also done it for commercial buildings. So building performance evaluation is the process of evaluating the real in situ performance of buildings with, I would say, more scientific methods. So what we do is visit the building, install sensors, and understand in depth how those buildings perform. What the HabLab studies has helped us is to provide accessible POE for clients. That means commercially accessible, because there are many out there doing building performance evaluation. But what we have developed together with the Glasgow School of Art, it's a methodology to make this commercially feasible. It helps us to understand existing performance and issues of buildings, define clear before and after performance, which is important to an important thing if you are if you actually want to prove how have you invested and where that investment went to. Prepare suitable retrofit recommendations, minimizing performance gap issues and unintended consequences. So we're using this information to prepare our retrofit strategies, and provide feedback loops to clients to know how their existing buildings are performing and how the retrofit recommendations, which we also evaluate, are actually performing. This, what you see right in this slide, are the type of test and equipment that we use or we can use for our building performance evaluations projects. Most of these projects are retrofit projects. We sometimes have evaluated new build projects to see how they perform, but we generally use it for retrofit projects. So we go to a building that hasn't been retrofitted or that has been recently retrofitted and evaluate how it is performing. The brief and exactly what to retest, it's defined at the very beginning with the client and discussed, and we base that on the available time and resources. But in general terms, we monitor energy consumption, that's gas and electricity. We monitor indoor air quality. I will cover this in the next slide, so I'll try to this is just a general overview. And building fabric measurements. And the last thing, but not least, is that we also conduct in situ surveys with occupants to understand comfort levels and understand how they use the buildings and how the buildings are impacting their comfort and health. So we've done this, as I mentioned before, for now about 7 years, and I will try to summarize in this slide what we have found in existing buildings or in buildings that had been recently retrofitted or improved. So the first thing is that for buildings that had where building fabric measures had been installed, we have seen that the buildings are generally more airtight and more efficient, but unfortunately not designed correctly, and that create gaps in the building, in the insulation layer and in the airtightness layer, which leads to heat losses, moisture, dampness, and indoor quality issues. The second point, it's ventilation and indoor quality. So the issues around that is that we found that warmer and more airtight buildings, sorry, that's a typo, can exacerbate health risks. Airtight, we do want, with this, I do want to clarify this, we do want buildings to be airtight, and we need buildings to be airtight, because that will ensure that that will minimize and reduce heat losses. It will reduce heating demand, and it will reduce carbon emission, CO2 emissions. But if we make them more airtight without developing a ventilation strategy, that would lead to poor indoor quality, which impacts the occupants' health and comfort. So airtightness is not a bad thing, it's a great thing, as you probably understand, but it needs to come together with a robust ventilation strategy. And the third point that we have found is that the retrofit works are generally too much focused in the building, and they underestimate the impact of engaging with people. So it's one of the biggest variable, how to engage with the building occupant, but also how to engage with contractors. And all of this is a missed opportunity, not informing well and not discussing this retrofit recommendations or works with the residents, and making sure that the communication, that everyone understands what are the purposes of a retrofit project, can lead to performance gap issues. So next couple of slides show some of the examples on how we use these techniques. For this specific project, we had to prepare retrofit recommendations, deep retrofit recommendations for a series of cross-wall properties. You probably have seen this buildings in Scotland and across the UK, but it's a mix. These properties have been built in the 1950s around, and they have a mix. The building fabric is a mix of cavity brick walls and infill walls. So we use thermography to highlight that difference, to analyze how the cavity brick walls were performing, where the issues were, and how the infill was performing. So if you see the thermography at the bottom, you see different surface temperature and how one wall was performing differently than the other. So we prepared, based on that recommendation, airtightness and insulation recommendations based on what we were seeing in the thermography survey. We also conduct airtightness test, which you probably know very well, so I'm not going to focus on airtightness. What I wanted to show here is that while we do airtightness test, which is the process of pressurizing or depressurizing a property with by installing a big fan that you see there on the picture, it's that we also do smoke pen test while we do this, conduct the airtightness test. The person in that picture is actually Tom Barber from Thermal Image UK, who does most of our tests. And what he does, and sometimes we do as well, it's to walk around with a smoke pen, identifying where the air leakages are And that's not a common practice or not necessary common practice and not requires in the building regulations, but it not only, so the end result is not going to be the general air tightness. We also will know specifically where the main areas of air leakage are. We also do U value, in situ U value to measure how different type in situ, what's the U value of different walls. This is a more intensive and time demanding and expensive test, but you can do it if you have the time and the budget. So this is things that we have done in the past to prove existing and improve performances. And we measure indoor quality to most of our projects. The minimum that we recommend to, if you don't have budget or time, or at least budget, the minimum that we recommend to monitor is relative humidity, temperature, and CO2. This will give you a good idea of comfort levels, risks of mold growth by knowing the relative humidity. But CO2, it's a proxy to have an idea how efficient the ventilation system is and how good the indoor air quality. And it gives us an indication of how, if there is a high concentration of CO2, that's not dangerous, that's not a worry, but it's an indication that there might be other pollutants affecting our health. So those three are give us a good idea of indoor air quality. If the client wants to do something more detailed, we, in addition to that, can do formaldehyde, VOCs, and particulate matter monitoring to analyze different type of things. It really depends on the project. And as I mentioned before, we conduct an occupancy survey. What you see there, it's a lunch that one of the residents prepared for me once, and of course I didn't ask for that, but that's one of the process that you have to go through. Well, it's, of course I welcomed it because it was great to have that, but sometimes occupancy surveys are not necessarily structured. It's about having a chat with the resident to understand in reality, without making it too formal, how they perceive their houses, where the issues are, how do they use their systems or not, if they understand where the ventilation controls are or trickle vents, and that's part of the process, and you need to take your time to do that. And we also measure the efficiency of ventilation by visually inspecting it. If there is a mechanical ventilation system, we take airflow measurements. What you see there on the top left, it's Chris measuring airflow with an airflow meter. On the top, sorry, that was top left. Top right, it's us checking the filters of an MVHR. And in the bottom, we're measuring the noise levels of an MVHR. We're checking the conditions of filters and measuring the energy consumptions of an MVHR. And the last thing is that we also, to all or majority of our retrofit projects, pre and post, we conduct an energy consumption analysis. If we can't install sensors, we ask for energy bills and try to analyze a couple of months of energy bills. If that's not available, we conduct meter readings. And if possible, we conduct in situ monitoring. And the last thing about HabLab, we engage with people, not only with residents. We try to do that throughout the process. From the very beginning, engaging with our with the client, trying to understand in deep the brief, conduct accurate modeling and inform that to the client. We try to improve every day the documentations that we provide to contractors. We try to improve the supervision and inspector on site, and try to try different methodologies to improve that, and try to improve the handover by preparing easy to read quick start guides. So in terms of retrofit strategies, I'll quickly go through that because we will actually also cover it during the case study. One of the most important things to take into account when considering retrofit strategies is the fabric first approach. Many standards that we have mentioned before, for example, EnerPHit and PAS 35, follow this approach, recommended as best practice guidance. First fabric approach intends to ensure that existing building fabric is as energy efficient as possible before considering new or before considering the improvement of active systems. When I'm talking about fabric, I'm talking about walls, roof, floors, windows and doors, the general envelope, and that includes thermal bridging and air tightness. So we should consider all of that. We'll have a plan, if we can do it immediately, have a plan for the future on how to improve that before considering active systems, which are heating, domestic hot water, and ventilation. It prioritizes improvement in 5 stages, bring the building fabric into good repair, so making them retrofit ready, and that's maintenance, that's not improvement. Improve the fabric, the building fabric, including insulation, air tightness measures by minimizing thermal bridging in order to reduce the heating demand. Meet the remaining heating demand using an energy efficiency space heating and domestic hot water system. And having added that, I should have added that as an additional bullet point, ventilation, considering ventilation before actually considering the heating and domestic hot water improvement. And once you covered all of that, after covering all of that, have a renewable system plan in place and this will offset the remaining energy consumption. So that doesn't mean that the active systems are not important. What it does, it prioritizes it, it puts envelope first. It gives it, it orders, it suggests a sequence on how you have to consider the measures. And that's the second, that's an example what you see there of a ventilation strategy that we prepared. It doesn't need to be, there are different systems out there. It doesn't need to be MVHR as EnerPHit suggests. If you are implementing another standard that it's not EnerPHit, you can use decentralized continuous extract ventilation or any type of insulation which is will ensure the indoor air qualities will maintain will be met, and it needs to be in line with the air tightness strategy. The other thing that I wanted to mention is that some of the retrofit standards that we mentioned before allow or have an option of implementing this retrofit measures in a step-by-step strategy. So a radical whole house retrofit, it's great, but many times there are great financial barriers, and even if there is a budget, there are disruption or people or properties are occupied. So it's sometimes not possible to do this all in one go. So EnerPHit and other standards, what you see on the right, it's a graph prepared by the Passive House Institute, and that's specifically for EnerPHit, suggest and prepared a way of implementing this in steps. One of the way would be to first improve partially or majority of the fabric. Let's say everything except the floor because people are living there, and also install the ventilation system to ensure good indoor quality. Second step would be heating and maybe domestic hot water system, and the third step could be renewables. LETI, which I mentioned before, has published a retrofit guide last year, which I really recommend you to have a look, because it's also free to download and they're doing great work. You can also volunteer and get involved. But the great thing about this guide is that it merges different standards and takes into account different standards, for example, passive house and EnerPHit, and also provides performance targets, which is actually based some of this on EnerPHit. So these are the LETI performance targets, and I suggest you to have a look. So I'll now I'll try to cover a very big and complex project, which is Niddrie Road, in the next 10 minutes. Try to keep time right, but if I don't have time to cover it, please feel free to contact me. I left my email in the first. My email is shown in the first slide, so I'm happy to answer any queries about this. This project, it reflects. I think we chose this because it's we wanted to show a very Scottish example for this webinar, and traditional sandstone tenement is, I think, and mainly red sandstone traditional tenements are a very Scottish example, at least for the central belt. The existing building, it's a pre-1919 tenement, for the ones who don't know them. They are all, you can find them everywhere in the central belt, mainly in Glasgow if it's redstone. The building is an 8-flat sandstone block located in the south side of Glasgow. It's owned by Southside Housing Association in 100%, and that's a key factor for retrofit, because if this would have been mixed tenure, or that would have been more complex, and maybe the methodology could have been different. So the building consists of one closed serving 8 flats, very standard sandstone tenement. Glasgow is estimated to have more than 70,000 of such tenement flats, and Scotland about 182,000. So finding retrofit solutions for this type of properties can have a huge impact. If this is EnerPHit or other standard, that's to be discussed. And what I'm going to cover in this case is what happens, or what are the implications of using EnerPHit to improve building of this type. These buildings have a significant cultural, historical, and urban value, but also have very poor thermal performance, having solid uninsulated walls, suspended timber floors, and high air permeability. We have measured it, and we measured actually many of this type of buildings, and it was in between 13 and 15 cubic meters per hour per square meter, which is very high air tightness, or very poor air tightness. So the description, when we started the discussion with Southside Housing Association, the project, they wanted to comply with EIS2, which is the energy efficient standard for social housing. And this standard, according to the Scottish Government, will contribute to reducing carbon emissions by 42% by 2020 and 80% by 2050. And what it suggests is that social housing should meet a band B by 2032. And that's an EPC of 81, so it's relatively high. That was the first compliant and first discussion that we had with the client. But the other discussion and need that they had is that the layout had to be radically, or had to be changed to improve accessibility and space conditions. And all the properties were void when we started this. So there was a great need to future-proof these properties, to understand how far we could go. They did wanted a deep retrofit approach and a radical approach. So we proposed EnerPHit because we still think it's the most robust and beneficial approach to meet Southside Housing Association targets, but also Glasgow City Council targets, which is one of the partners of the project. The project is, sorry?
Just 5 minutes left.
Okay, the project is funded by the Southside Housing Association and Glasgow City Council. We're now actually on site. The building, so what we were saying before, it's an insulated property. There were many challenges, for example, the orientation. Actually, the form factor was relatively beneficial, but the challenges were that it's heavily overshadowed, so we can't make use of the benefits of solar gains, which is a crucial thing for passive house. They are very small southeast facing windows and large amount of northwest facing windows. That means more heat loss than heat gains. And there were significant unavoidable thermal breaches. That's the existing, one of the existing elevations, front elevation and the floor plans. And as you can see, the WC had a very, very unusual layout, or actually usual layout for this type of buildings, which had to be improved. We started the project by doing a retrofit assessment and a building performance evaluation, which helped us to define the before and after performance, because we also going to plan to do it the post retrofit evaluation. It helps us to understand existing performance issues and base our retrofit recommendations on these findings. These studies included literature review, monitoring the environmental conditions, including temperature and relative humidity. We conducted hydrothermal modeling that was conducted by GreenGauge, in situ value measurements, structural surveys, rod surveys, and in situ moisture measurements. And you might have seen this image before, because it has been out there quite a bit. This is our strategy, and this is what we are proposing for the fabric and the systems. So we are proposing a whole house retrofit approach, which is very radical because there are no occupants, and this meant to be stripping off linings and lifting floorboards, but we were able to do it because that's what we agreed with the client and because the properties were unoccupied. In terms of the fabric, we approached a hybrid system where we are proposing internal wall insulation to the front to not affect the conservation aspect of the project, and external wall insulation to the rear and to the gable end. We proposed wood fiber for internal wall insulation, which is in line with the breathable sandstone walls, and rock walls for external wall insulation. We did try to specify wood fiber for the external wall insulation, but that had to be changed because of a budget restriction. And we did a good amount of moisture management studies before defining what was the thickness that we had to install for the internal wall insulation. The main worry was how this could potentially affect the joist ends. And one of the things that we did is to do hydrothermal calculations, which confirmed that what we were specifying for the external wall insulation was okay. The internal wall insulation was actually okay. It wasn't introducing any issues to the wall, but it was introducing issues to the joist ends. And after discussing this with the client, we decided to remove the vulnerable joist ends, which is very disruptive, but it was possible because in this particular case, because the properties were unoccupied. We are now measuring the moisture content of the existing joists, timber joists, and we'll leave the sensors in place for at least 6 months. It's on site now. We have installed a good amount of the measures, and also doing test and smoke test to make sure that what we are doing it's as per detail and it's performing well. So a couple of examples here. I don't have a lot of time, but to show you how we solved the thermal bridging issues, what we had, or what's the common practice, and how did we mitigate this thermal bridging issue. So what you see on the right, it's a base, wall base and foundation detail, how it would be usually installed, and the red lines are showing thermal bridging issues. And that's what we did, extending the EWI and insulating it internally to mitigate the thermal bridge. And we modeled it with Warm actually did, to prove that the thermal bridge was actually acceptable to meet passive house standards. Same for wall head details. And we also specified triple glazed windows, which is one of the requirements for passive house for this type of locations, geographical location, which was also in line with the conservation strategy. And it was a long discussion with planners to try to keep the existing architectural features. So triple glaze and timber frame windows. Last one, services. We have looked at many options for services. We've analyzed different type of renewables, which is a very big challenge for tenement blocks. And we finally, after modeling and analyzing different options, we end up installing a mix of air source heat pumps in the ground floor and first floor flats, and high efficient combi boilers, condensate boilers, to be able to compare these two systems and see what's feasible and what's, if air source heat pumps are robust and feasible options for tenement buildings. We also installed a wastewater heat recovery system, an MBHR system, centralized, and smart controls. Won't be able to cover the modeling results, but happy to cover that during the Q&A. And we prepared, last thing, we prepared a quick start guide for the future residents with very clear and simple guidance on how to best use the systems. And I think that's me. Thanks very much, and I apologize if I talk too much.
No, no problem, Barbara. Thank you so much. And you covered a wide range in such a short space of time. And I think if there's any questions on Niddrie Road in particular, please just pop them in the chat and Barbara can expand there. And thanks for sharing your insights into your approach, or John Gilbert Architects' approach, particularly around HabLab, and then the retrofit standards that you're adopting. That was really insightful. There'll be an opportunity to ask Barbara some questions in just a moment, so please post them in the chat and we'll get round to them in a second. I would just like to mention that we are working with Glasgow School of Art and John Gilbert Architects in developing Niddrie Road into an immersive learning environment through a 360-degree walk-through learning space, which will consolidate a lot of what Barbara's discussed today. And we hope to launch this by the end of March. So here's our next poll. So where within the built environment do you feel that low carbon learning, upskilling is most required within construction, design, policy and standards, or building services? Just keen to get your thoughts on that. Around construction and design being the most, and I think particularly when we're discussing the fabric first approach, that's really instrumental. Yeah. Yeah, we're just going to move on to our questions now, and we have a question, Barbara, from Mila. So she's asking, what type of deep retrofit, what are the sort of deep retrofit costs for a typical Scottish 3-bedroom semi, if you can discuss that, and are these costs prohibitive to homeowners?
I think it depends on I hate to say this, and this is probably not the answer you'll want to hear, but it really depends on how you're going to implement this, because you could have, one thing that I would suggest you to do is to do this with an architect or a professional who understands about whole house retrofit approaches and can prepare a plan that if a deep retrofit plan that if it can be installed in one go, that it could be implemented in stages. So the total cost will depend on how far do you want to go, how far you want to reduce the energy bills, how much you want to improve the indoor quality, and how much you want to improve or future-proof your building or your property. I think it's not cheap, but
yep.
It's an investment, because you will reduce energy bills and you will live in a warmer and a healthier home. I'm not going to focus on cost because it's very wide, but I would say it can start from £10,000 to what we did in Niddrie Road with per property. So
would there be
if it's a house or a flat, and it really depends on the performance target that you are aiming to meet.
Definitely. And would there be any maybe tips for homeowners that would maybe want to start that process that you could think of as an initial starting points?
I think they are. I think that what I really would recommend is to approach someone who is qualified to do a retrofit, prepare a retrofit strategy that is maybe qualified to implement PAS 2035 or EnerPHit, but that understand and professional who understands retrofit, and to get a plan for readings. I think or recommendations. You have the Energy Saving Trust or Home Energy Scotland, but I'm not sure if they will be able to assess and prepare a plan. They will maybe suggest individual measures which can improve to a property, which is not a bad thing, and they will also assess and recommend available funding schemes, but that's not necessarily a whole house retrofit plan.
Great, thank you. This question is slightly different, and the person that's asked the question is quite keen to understand. You talked about a lot of the equipment and what the monitoring, so what is the equipment and what the monitoring is for, essentially some of the equipment that you went through when you were discussing the Hab Lab, I think. Yeah,
so I don't know if you remember, I think if I can go back there, but what we have covered, there are actually so many sensors and equipments to do different things, but overall I would group them in this 4 groups. The first one is they can be used to measure how much electricity or gas you're consuming. You can also have an idea of that by asking your energy supplier to install a smart meter, for example, but these are small things and you can do that for free actually. So there are small things that you can do to start being more aware of how you're using your houses, which systems of your house are under, or which ones are the more expensive ones. With a smart meter, and what I do have a smart meter, and I also have other sensors. But what I do is I plug and unplug different things in my house, and by analyzing this, how much energy consumption the smart meter is showing, so you will know if it's that it's coming from a badly performing fridge, or that you might have to unplug. But there are small things that you can do from there to analyze and compare with best practice, and what. So if you analyze what an efficient building is consuming for gas and space heating, and see what you're consuming, you will know how far you are and how much you can improve your house if you are insulating it or installing new systems. Smart meter, I energy monitoring devices. You can buy relatively affordable relative humidity and temperature sensors. These sensors they became very affordable in the last years. There are different types, and some of them are not very accurate, but they will start to give you an idea of what are ventilation and indoor air quality conditions of your house. How healthy is your house? So that's also recommended.
Brilliant, thank you. We have a question from Ian in regards to PAS 2035. We know is for domestic retrofit, and he's also suggesting that EnerPHit leans towards domestic. Are these standards easily applied to larger scale commercial and educational buildings, for example?
Yeah, EnerPHit can be definitely applied to domestic. It's not necessary for non-domestic. It's not necessary for domestic. I used an example. I used Niddrie Road as an example because it's what we have been developing. But there are other examples there. PHPP and Passive House have a section for non-domestic, and it can be there are educational Passive House buildings and EnerPHit buildings. And so EnerPHit is also Passive House, and EnerPHit are also for non-domestics, just to clarify that. And what the other thing that I recommend is to look at PAS 2038, which is a new standard that has been published last year, and that's the PAS 2035 version for non-domestic.
Exactly, that's brilliant. Thanks, Barbara. Linda is asking, can you expand a little bit more on the modelling phase of the Niddrie Road project? And we just have a few more minutes, and we've got another question we'd like to answer. So just
sorry that I didn't have time to cover that. But so what we have done, we used PHPP and SAP to model these buildings. We are still doing a good amount of modeling, but to define the retrofit strategy and, let's say, construction package, we use both the design modeling tool that we use is PHPP, and we use it mainly because we think it's a very useful, accurate, and tool to define precisely projects that are going on site. And we also use it because it's the tool to prove compliance with EnerPHit. So we have done our calculations. Worm and Gray and Drummond also did. They checked and they analyzed and did the detailed work of making sure that what we were designing made sense. And what PHPP allows you to have, it's a very detailed idea of how the building fabric is performing, if the thermal bridges are mitigated or not. What you see there in the energy balance, it's where the losses and gains are. So it guides you on where you should invest more or trying to improve more. It gives you an idea if the windows are underperforming or if thermal bridges are still a problem, or if you have to add more insulation and so on. And we use also SAP to prove that these properties were meeting each two. SAP, it's a compliance tool suggested by the Scottish government. It has its limitations, but we are also using it, SAP and RDSAP, sorry, to prove that what we are recommending meets also the each two standards. I'm not sure if that answers the question. I hope it does.
It does, definitely, thanks. The last question is around modern methods of construction. So Elliot's wondering, what are the thoughts around using modern methods of construction through the application for the retrofit agenda, essentially? Do you think they have key links and benefits?
It's actually really good. I would definitely look at that. One of the standards that I had on that list of standards, for example, Energy Sprung, uses this modern methods of construction. It uses offsite construction to be able to control better the quality. We have tried to implement that for new build and retrofit. and based on one of our EnerPHit projects, which is called Crosswalls. And I showed it at the very beginning, but unfortunately, due to COVID, never went on site. We try to mix EnerPHit and off-site construction. So I think I would definitely look at it, but it's not necessarily the only thing to look at, but there are different standards there, and it allows you to control quality, and which you can sometimes if you're doing everything on site.
Yeah, it's definitely an area that has, I think, significant potential within the retrofit environment. So thank you so much this morning, Barbara, and thank you for everyone for joining. We've had some great insights into the benefits of retrofit this morning and that wider impact on the reduction of carbon, and that EnerPHit is an approach to achieve low carbon buildings, and the way we construct with care as well. Each month we will host a different topic on EnerPHit, Passive House, and within the retrofit family as well. So on the 1st of February, we have David Pierpoint, the CEO of the Retrofit Academy, who'll be taking on talking about PAS 2035, so the British standard for domestic retrofit, which Barbara has talked about today in more detail, and also that role of the retrofit coordinator within or under that standard. So please look out for it and sign up for it. Also, please ensure that you register your interest in the link that Danielle will have just posted in the chat for you, and selecting which area you want to upskill in. We will contact you once you sign up, register your interest. We will contact you with different options and available courses and associated dates. Please be aware that some training has limited availability as well, so sign up quickly. Before we finish up today, we have our final poll. What area of low carbon learning would be most value to you and your business? Would it be passive house standards, EnerPHit standards, retrofit coordinator training, or awareness of all of the above? So yeah, we're really now pushing for, across the board upskilling. So that's excellent to see, over 60% there. Thank you everyone for joining this morning, in particular to Barbara and also John Gilbert Architects for supporting our low carbon learning programme. We hope this project has the desired impact that is to work towards a net zero built environment, and thanks to all the coordinator team behind the scenes for making today's webinar so seamless. Thank you so much everybody, and have a great afternoon.
Thank you.